Hello guys, in this video let us take a look at a question from network theory in GATE EC 2023. So for the two-port network shown below, the y parameter is given as y is equal to 1 by 100, 2 minus 1 minus 1, 4 by 3, and this is Siemens, the unit for admittance. The value of load impedance ZL in ohms, so ZL is given here, for maximum power transfer will be dash, round it off to the nearest integer. So now if we take a look at the circuit, in the input we have a 120 volt voltage source with 10 ohm source resistance, let's say, and you have a two-port network whose y parameter, that is the admittance parameter, is given, and you have a load ZL. So we need to calculate the load impedance ZL for maximum power transfer. So first let us see what this y parameter, admittance parameter, will look like. So your impedance is nothing but V is equal to I into Z, right? I into R. Similarly, your admittance will be nothing but I is equal to V into Y, or you can also write it as Y into V. So now for a two-port network, your I and V are matrices, right? So there will be I1, I2, and you have your Y parameter, which is relating your V1 and V2. And this Y parameter is nothing but you will have Y11, Y12, Y21, and Y22. So now if you relate this and write, you will have I1 equal to Y11 V1 plus Y12 V2, and I2 is equal to Y21 V1 plus Y22 V2. So this one you can write it out without memorizing anything. So this is just relating your input and output current to your input and output voltage. So if this is V1 and this is I1, and if it is V2 and I2, this is what is the relation. So now how will you transfer this into a circuit? So we can take a look at it. So we have V1. Now we want I1 such that your I1 is equal to this value. So what you will do? So Y11 V1 we can directly get from V1, right? So this is plus minus V1. So if I just put a resistor of value 1 by Y11, or we can say admittance of Y11 here, then my current in this will be V1 into Y11. But I also want another term which is related to V2. So my V2 is somewhere here. So I don't have a direct relation. So what I will do, I'll put a voltage control current source whose value is equal to Y1 to V2. Okay, now the input side is taken care. Similarly, on the output side, what we have, we want I2 equal to this quantity. So then what we have to do, it is Y21 into V1. So V1 is here. To relate it, we'll again put a voltage control current source, Y21 V1, right? And then we also want Y22 V2. Y22 V2 we can directly get by connecting an admittance of Y22 across V2. So now this is your circuit. So in the actual exam, you can skip all these and directly come to this state. So from here, what you have, from here, you connect your rest of your input and output in the circuit. So what you have here, you have 120 volt, 10 ohms. 120 volt, 10 ohms. And on the output, you have ZL. And if you have to write these Y11, Y12 and all, we can write it from the Y parameter. So your Y11 is 2 by 100. So which is nothing but 1 by 50. So in ohms, it will be 50 ohms. Similarly, your Y22 will be 4 by 3 into 1 by 100. So 300 by 4, which is 75 ohms. So I'm writing it in terms of resistance instead of the conductance. And your Y12 is minus 1 by 100 and Y21 is also minus 1 by 100. So this is minus V2 by 100 and this is minus V1 by 100. So now for maximum power transfer, what I will do, if I just consider this part of the circuit as some Thevenin voltage VTH with some RTH resistance, then I have this ZL. So now from this, if I find IL and power consumed by ZL, I'll get PZL is equal to IL square into ZL. And your IL is nothing but VTH by RTH plus ZL whole square into ZL. So now if you minimize PZL with respect to ZL, you will find that your value of ZL will turn out to be RTH. So this is the condition for maximum power transfer. This is what they're asking us to find. So we just need to find the RTH value. So looking into this circuit, we need to find the RTH value. So now let us find it. So now if you look here, to find RTH, what you have to do, you first need to disable all the sources. So you need to short your voltage source, right? And both sides, for reference, I can take this node as ground, right? So now, since these two-port network contains controlled sources, I cannot directly find my RTH by simplifying the circuit. So what I will do, I will connect a voltage source here of value, let's say V, and then I'll find the current drawn by the circuit. Then my RTH is nothing but V by I, right? Okay. So now let us proceed with that. So this is my V2 and this is my V1. So my V2 is now equal to V. So my I2 will be nothing but, I2 is nothing but I, which is nothing but Y22 V2, right? And Y22 is 75, 1 by 75 ohm. So it is V2 by 75 minus V1 by 100. So now we need to find V1. So let us go to this part of the circuit. So what we have here, V1 by 10 ohm plus V1 by 50 minus V2 by 100 equal to 0. Just KCL I'm writing, okay. So now V1 into 5 plus 1 by 50 is equal to V2 by 100. So V1 into 6 by 50 is equal to V2 by 100. So this is 2 times. So V1 is nothing but V2 by 12. So now if you substitute this in this equation, so you put 2 in 1, what you will get? Your I is equal to V2 by 75 minus V2 by 1200. The 1200 is nothing but 75 into 4 is 300 into 4 is 1200. So this is V2 by 16 minus 1 by 1200. Taking LCM, and this is nothing but 15 by 1200. So this 5 times this 400, 1 and 80. So your I is equal to V2 by 80, and we saw that your V2 is nothing but equal to V. So this is V by 80, and your RTH is V by I, which is V by 80, which is equal to 80 ohms. So your ZL for max power is equal to RTH, which is equal to 80 ohms. Okay, so the answer is 80 ohms.